Chapter 18, Problem 11 reads, the resistance between terminals A and B in the figure is 75 ohms. If the resistors labeled R have the same value, then determine R. So what we can first do is these two resistors over here are in series with one another, so we can add these two together and give it one value. So we can use the equation, the equivalent resistor equals to the addition of all the resistors in the series, and we can replace those two resistors with one value, which is R1 plus 5 ohms, so that would be R plus 5. Next, we see that there are three resistors in parallel with one another, and we can also replace that with one value. So we use this formula, which is the reciprocal of this one, and we end up getting 1 over 120 ohms plus 1 over 40 ohms plus 1 over R plus 5. And that simplifies to 1 over 30 plus 1 over R plus 5. Now, if we set that back equal to 1 over the equivalent resistor, and we find a common denominator, we can simplify to that to one value, which is 30 times R plus 5 over R plus 5. So now we have two resistors in a series, which is R and the value we just got. And we can even further simplify this to one resistor by adding the two together, which is R plus 30 times R plus 5 over R plus 35. So in the equation, they said that the total or the equivalent resistor is equal to 75 ohms. So we can set what we just got to 75 ohms. Next, we can find a common denominator and further simplify the equation, and then cross multiply to get this equation and simplify that into a quadratic equation. And with the quadratic equation, we can get these two equations, set them equal to 0, and solve for R. And we get two values for R. One is R equals 55 ohms, and one is R equals negative 45 ohms. And it can't be negative 45 because a resistor cannot have a negative value. So the answer ends up being R equals 55 ohms.